Hello everyone, welcome back to the video lecture series on 8086 microprocessor and its pin diagram. So in the last class we discussed about, or in the last series we discussed about the various pins in the minimum mode, and here we will discuss much detailed about maximum mode pins. So we can see here the maximum mode pins are generally assigned from pin number 24 to 31. In the other words, we can say that it is reassigned. During maximum mode operation, the MN/MX mode is grounded, that is logic low, and the pins 24 to 31 are reassigned. Here you can see that S0, S1, S2 and the status are the status signals, and they are used by the 8086 bus controller to generate the bus timing and control signals. These are decoded as shown: the status signals and the machine cycle. Generally, you can see that the values are assigned from 0 to 7 for 3 bits, and the various values are assigned for each status signal. And you can see that here it is S0, S1 and S2. So when it is 0, it means that the interrupt is acknowledged, and when it is 1, it is the read input output port, and when it is 1, it is a write input output port, and when it is 3 or 0, 1, 1, it is halt, and when it is 1, 0, 0, it is the code access, and when it is 1, 0, 1, it is read memory, and when it is 1, 1, 0, it is the write memory, and when it is 1, 1, 1, it is passive or inactive memory. So generally, these pins are assigned in the values from 28, 27 and 26. That is, 26 stands for S0 bar, and 27 stands for S1 bar, and 28 stands for S2 bar. So depending upon the value selected here, the different machine cycles will be executed. So this is the function of the status signal when the pin number 33 is said to be in the maximum mode signal. So now moving to the next one, that is the Q signals. So Q signals, QS bar, QS0 bar and QS0 1 is assigned to the pin number 24 and 25. These are called as the Q status. The processor provides the status of the queues in these lines. The queue status can be used by the external device to track the internal status of the queue in 8086. The output on QS0 and QS1 can be interpreted as shown in the table. So QS0 and QS1 are 2 bits, and hence the values are assigned from 00 to 11. So if it is 00, there is going to be no operation, and if it is 01, the first byte of an opcode from the queue, and when it is 10, the queue is completely empty, and when it is 11, subsequent byte from the queue can be taken up. So this is how the queue status is being represented by 8086 in the maximum mode signals. So now the remaining buses, that is RQ bar slash GTO or GT0 bar. Similarly, RQ bar slash GT1 bar. This is nothing but the bus request or the bus grant. These requests are used by other local bus masters to force the processor to release the local bus at the end of the processor's current bus cycle. These pins are bidirectional, and the request on GT0 will have high priority than GT1, and an input signal activated by the lock prefix instruction is given by the lock bar. This remains active until the completion of the instruction prefixed by lock. The 8086 output on the lock low pin while executing the instructions prefixed by the lock to prevent the other bus masters to gain the control of the system bus. So this much is about the maximum mode signals. And next we'll move into the microprocessor architecture in the forthcoming video lecture series. Thank you.